Good morning, students. Am I audible? Okay. So, in the last class, we have discussed about Kennedy's theory, and I think we have also discussed about Lessie's theory. Lessie's theory we have discussed. Yes. So, I think we have solved numericals also related to our Kennedy's theory. Am I right? I think we have solved this numerically, right? In the last class. Okay. Okay. Fine. So, we move on to the next numerical. So, kindly write down this numerical. Okay. That's 5.10. Designed by Kennedy's theory, when discharge is given 15 meter cube per second, Manning's N is also given, width of the channel divided by depth. The ratio is also given 7. Okay. Side slope is given. That means we are going to consider as a trapezoidal channel. Okay. And severe critical velocity ratio, that is MR, is also given 1. Okay. So first you kindly write down the numerical. Discharge is given, Manning's N is given, B by Y ratio is also given. And in this question, our side slope is nothing but your half, or you can also write 0.5. Okay, so our Z value is nothing but half or zero point 0.5. Okay, So first we are going to use the area equation of a trapezoidal channel. Okay. So here in this equation, z value we are going to substitute half. Okay. So that y square we bring it out, then we are going to get b by y, because why? What is our intention to make this b multiplied y to b by y? Because we have value for this particular ratio, that is b by y is already given, that is 7. Okay, so that is why if we bring it out y square, then this term will be your b by y. Okay, because if you multiply again, then you will get back to the last step. Okay, if you multiply, then you are going to get by. Okay, and then y square is bringing out, then we will be having half. Okay, so this is nothing but your 7. This is b by y is nothing but 7 plus this is your zero point 0.5. Okay, so this thing you are going to get 7.5 y square. Okay, so then okay, so you got an expression of area. Okay, area is equal to 7.5 y square. Then we are going to use the velocity equation. This equation we have already discussed, okay, in kinetics theory, that 0.55 multiplied by critical velocity ratio multiplied by y to the power 0.64. Okay, so here in critical velocity ratio is given is equal to 1, so we had directly substitute here 1. Okay, so if we again simplify, we will get another equation of velocity is equal to 0.55 y to the power 0.64. Okay, then we use the discharge equation. Okay, so we know discharge is equal to nothing but area multiplied by velocity. Okay, so area we have one expression. Okay, velocity also we have another expression. Okay, so we'll substitute here. We substitute here. Okay, and the discharge value is already given in the question. That is 15 meter cube per second. Okay, so we are going to substitute here discharge. Okay, and if you see in this equation, you have only one unknown, that is y value. Okay, so from here you can find out the y value. Okay, so you try to find out y value and you are getting the same value or not. So what we have to do first, we have to use the area expression of trapezoidal channel. Okay, then okay, area, then we are going to get an expression for area with the y unknown. Okay, that is 7.5 y square. Then we use that velocity equation, that is 0.55 multiplied by critical velocity ratio multiplied by y to the power 0.64. Okay, so from that equation we are going to get another expression of velocity. Okay, then we are going to consider the discharge equation, that is area into velocity. So in place of area we are going to substitute the area expression, and in place of velocity we are going to substitute that velocity equation. Okay, so if you further solve, because that discharge is given 15 meter cube per second, then we can directly find out the y value. Okay, and check you are getting that y value is 1.60 or not. Okay. And once you find out the y value with this V by Y ratio, you can also find out the width of the channel. Okay. So you find out the Y and V value. Okay. Over. Getting the Y value 1.63 meter. Okay. And width of the channel 11.415 meter. Okay, fine. Okay. Okay. So now what we have to do, I think this equation is familiar to you all. Okay. This equation is familiar to all. Okay. So now we have to use this equation. Okay. Here, the velocity, here this velocity we are going to substitute the velocity we have calculated by this equation. V is equal to 0.55 multiplied by mr. Mr is nothing but your critical velocity ratio y to the power 0.6. Okay. So y value we have already calculated. Mr is given, it's given as 1. Okay. Y value we have calculated. So we can find out the velocity. And that velocity we are going to substitute here. Okay. Now see, in this equation, another two term is there. One is your bed slope. Okay. One is your bed slope and one is your hydraulic radius. So R value you can calculate by A by P. Okay. Okay. So you first find out the area because the area expression is already there with you. Okay. Only we have to substitute the Y value and we have to find out the area. Okay. And then you find out the weighted perimeter. Okay. So you all know how to find out the weighted perimeter of a trapezoidal channel. So first you find out weighted perimeter And for area, you have that expression is already there. Okay, that area expression is already there with you. Only you have to substitute the y value that we have calculated. Okay? The y value you have calculated, substitute here in that area equation, and you find out the area, and you have to find out the weighted perimeter of a trapezoidal channel. Okay, and then you find out the r value. Okay, so first you find out the area, then you find out the weighted perimeter of a trapezoidal channel, and then you calculate r. Okay, 348 meter. When you do, you see here it's given 1.2683. Okay, here it's given 1.2683 meter R value. So you people check it once again. Though you people are almost same, but you are getting above 1.3. Okay, so we can consider also 1.3. No issue. That be sorry, R value you can consider as 1.3 meter. Okay. So here in this equation we have to substitute that R value. Okay, we have to substitute that R value, then that velocity. Okay, R value and velocity, and we have to solve for SB. Okay, so try to find out the SB value from this equation. Okay, so R value is already known, or we have already calculated, that is 1.3 meter. Okay, or you can take 1.26, it's up to you. And you try to find out the bed slope from this equation. Okay, see, manually it is very difficult to find. Okay, because it's a very big calculations. Okay, if you bring this SB in one side, it will take some time. Okay, so definitely this type of numericals we solve with the help of some mathematical software. Okay, like MATLAB. Okay, so what we do in that software, we code that program in such a way that we are changing that SB value in such a way that the left hand side is equal to right hand side. Okay, this is your left hand side. Sorry, this is your right hand side. This is your right hand side, and this is your left hand side. Okay, left hand side. Okay. So we vary this as value, SB, sorry, bed slope value, till we are getting left hand side is equal to right hand side. Okay, left hand side is equal to right hand side. So again, we have already discussed that our Kennedy's theory is an trial and error method. Okay, so that is why this part is again it's a trial and error method. Okay, okay. So I think you people remember about the freeboard. Okay, about the freeboard. If the discharge is less than 10, then we can provide 0.67. If the discharge is greater than 10 meter cube per second, then we can provide more than 0.75. Okay, so this is nothing but your freeboard. Okay, the SB or the bed slope of the channel you can find out by this equation. Okay, Y value we have already calculated, and then we provide some freeboard, and then our actual or design depth will be 2.3 meter. Okay, and for that particular depth our 11.5 meter is the width. Okay, because we know we have a ratio b by y is equal to 7. Okay, once you change the y value, then our b value is automatically changed. Okay, so whatever the y value, after adding free board you are going to get, that is 2.3, then your b value is nothing but 7 into 2.3. Okay, so this b is your design width of the channel. Okay, so do you have any doubt in this numerical? So we have two types of numericals in Canada's theory. One, that we are going to follow the step by steps. Okay, and another one is this, when you have that b by y ratio. Okay, if you have that b by y ratio, you are going to follow this method. Okay, so if you have any question, we can discuss now. Okay, next is our Lesis theory. So I think we have already discussed about Lesis theory, but I'm going to discuss today once again, just to brush up in a brief manner. Okay, okay. So these are the steps for designing a kernel by Lesis theory. Okay, so first step, to design a kernel, we always require the discharge. Okay, for what discharge you are going to design that particular kernel. So in the Lesis theory, these parameters should be known. Okay, to follow this theory, one is your design discharge, or you can say discharge. One is your size of the bed materials. Okay, and that size should be in mm. Okay, then side slope. Next is side slope. If it is not given, then assume half horizontal is to one vertical, or one horizontal is to one vertical. So if it is not given, it is always suggested to consider one horizontal is to one vertical. If you consider this, then your z value is equal to 1, which simplify your calculation. Otherwise, you can also consider that z value is 0.5, or you can say 1 by 2. Okay? But it will, if you consider z equal to 1, then your calculation is simple. Okay, so if it is not given that side slope, so always use consider one horizontal is to one vertical to simplify your calculation. Okay, so these are the data you should know before you follow this theory. That is your lattice theory. Okay, one is your discharge size is D in mm. That is your size of the bed material. Then side slope. Okay, so your first step is to find out the silt factor. Okay, the silt factor is nothing but 1.76 root over D. Okay, silt factor is nothing but 1.76 root over D, and this D is nothing but your size of the bed material in mm. Okay, you have to substitute this value in mm. Okay, so otherwise you are substituting the value in centimeter or meter, then you are going to get a wrong answer. Okay, so it's always suggested to put this value in mm. If in the question your sediment size is not in mm, then you have to convert into mm, and then you have to substitute here. Okay, then next is to find out the velocity. Okay, next next step is to find out the velocity using this equation. Okay, v is equal to qf square divided by 140 to the power 1 by 6. Okay, so q is nothing but your discharge, which is already known. Friction factor, sorry, it is silt factor that you have already calculated in step number 1, divided by 140 to the power 1 by 6. Okay, so you kindly write down the steps. If you have these steps, then it's okay. Otherwise you write down the steps. When we go for numerical, it's required. Okay, because we have to follow step by step. Okay, so you write down this equation, that is vc equal to qf square divided by 140 to the power 1 by 6. Okay, so in the first step we have calculated silt factor. In second step we need to find out the velocity by using this equation. Okay, q f square divided by 140 to the power 1 by 6. Okay, to the power 1 divided by 6. Okay, so this is our second step. Okay, third step, again we need to find out the area, that is q divided by velocity, that is known to all of you. Then we are going to use the area expression for a trapezoidal channel. Okay, in that area expression, y value is not known to you. Okay, width of the channel is not known to you. Okay, so b and y is not known. Z value, if it is given, then it's okay. If it is not given, then we are going to consider zero point 0.5 or 1. Okay, then we are going to use, because see here we have two unknowns, one is width of the channel and one is depth of flow. So we need another equation. Okay, another equation to solve this. Okay, in one equation if you have one unknown you can solve. Okay, in one equation if you have two unknowns then you cannot solve, so we need at least two equations to solve two unknowns. Okay, so that is why in next steps we are going to consider the weighted perimeter of a trapezoidal channel. Okay, so here in this equation that area is known to you because you have calculated by using this expression. Okay, so here we have two unknowns, but in weighted perimeter your width of the channel is not known. Z value we can assume, y value is not known, but the weighted perimeter also not known. So the radius gives an equation to find out the weighted perimeter, that is p equal to 4.75 root over q. Okay, so q is known to you or it's given. So from this equation you can find out the weighted perimeter, and that weighted perimeter you can substitute in step number 5. Okay, then you will be having two equations with two unknowns. Okay, we'll be having two equations with two unknowns. So you can solve both the equations and you can find out the y and v value. Okay, so you kindly write down the steps. Okay, and the next step is to find out the bed slope. Okay, using this expression. Okay, so you just write down this expression and then we will go for numericals. Okay, so you write down this numerical. Okay, 5.11. Design a canal, or you can write channel by Lacy's theory for a discharge of 40 meter cube per second. The side slope may be assumed as one horizontal is to one vertical. The average size of bed materials may be taken as 0.8 mm. Okay, see, that this meeting is going to end. Okay, so I'm going to end this meeting, and then again we are going to start. Okay, without any break. Okay, then we solve this numerical. Okay, so there will be no break today because we are already late today. Okay, so we are going to end this meeting now, and then we are going to start again without any break. Is it okay?